Hello, everyone. Thank you for joining me today here. So I'll start with you, Sean. So how is NVIDIA leveraging spatial AI to solve these complex problems of geospatial, around geospatial these days?
We think of spatial AI as, we call it, you can call it spatial, but really what forms the essence of the world around us is the physics of the universe. That is what we're trying to understand, what we need AI to understand to interact with all of us, to robots and autonomous devices, including cars, which I'll talk about. We develop hardware, we develop software. Jensen announced Omniverse with Cosmos. So let's take it in the context of autonomous driving. An autonomous vehicle, robots, otherwise, you've got a computer in the car. And the computer is connected to the sensors. And the sensors are feeding information to the computer, and the computer is figuring out what to do. That's called inference, AI inference. It's inferring or guessing what's its next step based on a model that's living on that computer. It's a very small computer. So for autonomous driving, how do you teach an AI about the world that it's going to be driving around in? Well, one way is to scan the world, and driving around with LiDAR and other types of sensors, scanning the world, and you get a great resolution of the streets. Now the car can understand where to drive. But what's missing from that is dynamic situations that the car is going to encounter as it moves around, scenarios and different conditions, because that capture, the voxel map's done, is captured at a point in time. So we need to embellish that data in the form of scenarios and conditions. And that is done by building a digital twin. And we can start building the digital twin with all of these reality capture scans. Once we have the 3D data in Omniverse, then how do we create these scenarios? Well, this is where AI comes in, because Omniverse is a 3D application. There's more data that you might want to bring in: geometry, BIM from Autodesk Revit, city models from S3 City Engine you can generate procedurally, Trimble SketchUp models. All of this can come into Omniverse because Omniverse is based on open standard called USD, or OpenUSD, Universal Scene Graph Description Language. So it makes it very easy to get geometry, 3D geometry, into Omniverse. And now we start adding context and creating these scenarios. And we could use AI to say, well, I want to create a construction scenario, like a construction block up here where we close a lane. You can actually type that into an LLM, and Omniverse will go and fetch 3D assets like Entourage, construction signs, and construction workers. And those construction workers can be actually like informed by physics, so they walk the right way. Now we could render out all of these scenarios, and this is all training content for AI. And it's all informed by physics, because at the heart of this, the way the people walk, the way the cars drive, all of that is all informed by physics. So where does the Cosmos part come in, the generative AI? Here's the source of the scene. Take this, use it as a reference. I'll give you some prompter words. Now make it look perfect, make it look real. Now you do what's called domain randomization, and you go from one 3D scene that you've scripted with these scenarios, like a kid jumping into a car, into that happening at day, at night, in traffic, winter, summer. Now you're starting to get tons of data for the AI. And this is where all that data comes in. The AI learns the right way, the wrong way to do things. Eventually the model gets deployed into the little computer on the car.
Thank you, Sean.
Yeah.
Andy, Outrun Media is one of the leading advertising companies. How critical is near real data location and point of interest for sales growth? And how do you see the evolving role of AI and spatial computing in integrating geospatial and location information in workflows of advertising industry?
We set out to solve a problem, which was a traditional media entity like ours is in the physical space, billboards all around the country. And we needed to compare our value of the advertisement that's put there versus something that's being in linear television or something that's on the web or something in social media. And the only way to do that was to create a measurement system that was comparable to what others have. And whether it's a one-to-one relationship on a web interface or on a mobile interface, we are one-to-many, and we are in the physical space. And so geospatial data integrated into a tool we built, which was called Smart Scout, allows us to assess in real time the number of people and the demographic and behavioral segmentations of those people as they are moving past any one of our assets. assets. Based on that, we can then put that up against everything else in the media marketplace and create an active market for our media, which was never possible before. So it's been a phenomenal success.
Wow. So Jerry, good to have you. I would like to know about Regrid, how you are providing parcels and property information products, and that's valuable for several business enterprises. How do you view innovations and spatial computing as enabler of integration of your products with workflows of your enterprise customers, especially in delivering last mile connectivity and beyond?
We are in the collected facts industry. Our collected facts happen to be property boundaries. We call them parcels or land parcels, but property boundaries, ownership, assessments, zoning, buildings, everything back to a property, but the spatial component, the geometry. And we have a very large spatial data set. We cover 100% of the US, most of Canada, and increasingly international. And so sometimes I'll challenge the team when we talk about topics related to spatial computing and AI. I'll say, the natural heat death of the collected facts industry is for everything to eventually end in a tie. And I say this to the team because so much of our work goes into being accurate, being true, finding these things, putting them together. But we do need to find ways to go beyond this. We need to be able to say new things about these facts. We need to be able to derive new insights about these facts. And we need to be able to crunch through more facts more quickly than we ever have. There was a demonstration of our nationwide parcel data inside of Esri's big data toolkit. The demonstration was, okay, I need to find land parcels that are of a very specific size. They are of a certain type of zoning. They are of a certain type of ground coverage, so surface coverage on the parcel, and they are of a certain proximity to an interstate exchange. Okay, crunch this, and then boom, here comes back the 3 dozen parcels that could possibly meet this criteria across the United States in nanoseconds. A lot of our customers use our data in AI applications and spatial computing, and what does that mean for us? It means that we need to be very conscious that we can deliver our data set into the systems that they want to use. From building some of these, I don't know if you'll call them AI as much as machine learning pipelines, where we take our parcel geometry and all of the attributes that go along with it, superimpose that on imagery, and then train the model to say, okay, so these fields correspond with something that looks like this in the world, and then start to show it places and things in imagery that it's never seen before, and have it accurately classify and add new data to it. So this movement from fact collection to data creation and saying new things and being able to crunch it faster is a huge part of our world, and I'll leave it there for here.
Moving on, Whereabouts to Gia. Spatial computing and AI is appearing to be the integral part of your product. What is your offering for business enterprises, including companies, represented on this panel?
So at Whereabouts, we are offering basically 2 products. So the first product, we call it Whereabouts DB. So Whereabouts DB is a cloud-native geospatial data warehouse that is tailored for geospatial analytics. And users can interact with Whereabouts DB through Spatial SQL, Spatial Python, and Whereabouts DB automatically scale out the workload to hundreds of machines on the cloud. So that means the scalability is no longer a problem. Take Whereabouts DB, and Whereabouts DB is going to be able to accelerate and scale out the data ETL process for their parcel data, for their aerial image data pipeline or workflow to a greater scale. The second product Whereabouts offering is, we call it Whereabouts AI. So Whereabouts AI is built on top of our Whereabouts DB infrastructure. So it is a platform that can run AI and machine learning models, in particular spatial statistic models and spatial computer vision models. It can run these AI and machine learning models on massive geospatial data sets, advanced models on the aerial images to perform tasks like classification, object detection, and segmentation. And both of the products we offer at Whereabouts, so they deliver results at a much higher speed and at a much lower cost. So that is our pitch.
Moving on to Peer. Peer EagleView is well-established name in geospatial data capture and management for insurance and real estate's market. How do you see the role of spatial computing and AI in integration of Earth observation and aerial or drone imageries and its combined value for the business processes of your customers?
So EagleView, we're one of the OG aerial capture firms, and this idea of spatial computing and AI is really at the core of what we do. It's in essence a lot of our value prop. And when we think about spatial computing, we really think about the integration of the digital to the physical world. EagleView specifically thinks about that and how can we solve some very high value, mission critical workflow types of problems. So we really, our anchor kind of use cases came from tax assessment and insurance claims workflows by being able to take highly accurate, high resolution, oblique imagery, being able to extract these 3D wireframes and find something very, very useful. Something with very, very high ROIs, the kind of data that you can't live without through good times and bad times. And we're really excited about even further that agentic AI coming around the corner, and this is what enables us to democratize and take AI insight extraction from the realm of experts to the realm of everybody.
Thank you for sharing your insights. As of now, we touched upon specific industries that each one of you are catering to, but we'll have to look at larger gamut of various technologies, various industries, where this technology is being deployed. So your take on that?
We have a project called Earth 2, which is based on Omniverse, and the goal is to create a digital twin of the planet. And we can use that digital twin to study climate change. And using this platform, which is based on surrogate data for like computational fluid dynamics for training, we can train an AI model to understand and predict weather systems. So we have this digital twin of the Earth, the ability to physically simulate atmospherics, so it's totally accurate down to a voxel level, and the ability to inform that simulation with an AI model that's going to predict, for example, the path and behavior of typhoon. So now we can start populating our digital twin with geometry. So for example, Earth 2 comes with a base map from cesium of the whole Earth in 3D terrain. And what we want to do is save lives by predicting the impact that weather events, climate change events are going to have on the ground. We're using this digital twin to simulate these different scenarios based on real AI predicted weather so that we can generate synthetic data to train an AI. What's the impact of that typhoon on the ground? Where's the flooding going to occur? Who should we evacuate? Where should we dispatch emergency resources for fire? How can we mitigate in advance and save lives? This is the opportunity of digital twins for our planet.
So from a workflow standpoint, when you are an advertiser and there's $320 billion a year spent in advertising in the United States, you're trying to make the best decisions around for your client. If you're usually an agency making these decisions, how do I advertise to the consumers that are most appropriate for my particular project, whatever that is? And in the out-of-home space, we were never able to participate in that because we just didn't have the data to be able to compare to what's going on in the digital world. And so now that we've got that ability, you can use the predictive models to understand if I'm looking for millennial Hispanic females in New York City between the dates of September 1st and September 30th, I can understand historically how many of those folks were at each of those individual sites and index each site against those demographic and behavioral segmentations, and then predict for that next period of time while I'm buying the advertising, what are the most appropriate ones to do it at a value relative to other places to do that. But then you have to have a mix of that, because having one media is not necessarily the best. You want to have something along the entire customer journey. So what they're doing when they're home and they're on television, what they're doing is they're driving to work, what they're doing on their computer when they're at work, and then all the way back. And so this entire ecosystem now we can now participate as an out-of-home company in that ecosystem, which we didn't have the chance to do before.
One lesson that we've really seen, something we've seen come into focus over the last year or so, has been on this data delivery component, right? So like whether it's, like our data is in a Aware Robots instance as well, right? So it's easy for us to deliver to a customer that way, and we deliver through all major cloud environments, and the list is kind of endless there. But and that makes a difference, because I'm finding as people do more AI and spatial computing, the other thing I want to mention on this too, because I think this is important, for those of us that consume, use, provide data, and all of us who are interested just in this, under this greater theme of collaboration that runs through these events, the permissiveness of the data usage gets really interesting too, because I feel like there's a lot that can be mashed up and enriched and put together spatially, where you've got data coming in from lots of different businesses. So I think there's some work to be done to really make these things sing of like how to get the right permissions and collaboration in place.
I think your spatial compute and the AI workflow should run on the cloud, should live on the cloud instead of on your self-managed data centers. And this is just because I think most of the cloud vendors, they are offering better and safer and more reliable cloud services than you manage stuff yourself. And the second thing is when you adopt infrastructure, you should really consider a compute and storage separated, decoupled system architecture. So what does that mean? So that means, compute and storage, they can scale up and scale out independently without over-provisioning, without impacting each other. That means your storage can be hooked up with any kind of spatial workflows, and you don't have to, whenever you want to use new spatial workflow tools, you have to migrate your data. You need to copy, replicate your data again, right? So that's the second thing I think that is really important. The third thing I think, geospatial data is inherently massive, and it is also growing rapidly, as we all know that, right? So if your infrastructure does not consider scalability, that means in the future, if you want to solve this problem, it's going to be extremely costly, or it's going to be really time-consuming for you to migrate your infrastructure.
Right now, I'm very focused on the insurance industry. I live in Florida, on the coast. By being able to better model and understand the risk and understand how to mitigate some of those risks before they happen is really critical. So that's part one. Part two, this is the piece that people really, I think we tend to not think about so much, and it's the education to the masses and the building owners and the homeowners and the insureds out there, and the change management that we need to get ahead of as we start to implement these models and these technologies, particularly when you're talking about AI-generated models, which are black boxes, and there's a lot of proprietary science behind a lot of those answers. Because what we're already seeing here is just a lot of uncertainty, and there's a lot of folks that are coming back, and they absolutely are sure that Eagle View is flying drones on behalf of the insurance company so that they have a way to cancel their policy, when in reality we do nothing of the sort, right? But that's just the perception, and you need to have somebody to point at. And it's really easy to point at geospatial data, really just a view of what is fact and making that the boogeyman. And that's a big problem, and I think it's something that we really need to put some calories on trying to solve.
With this, we come to an end of this amazing panel, and I would like to thank all my panelists for being here and joining me on this stage.